Hello community! Today we face a problem that you know. We have a complex document, another complex document, a real complex document, and we provide them to our LLM, and you know what? The complexity of the technical content of those documents, given finance, biology, physics, mathematics, is too high for our LLM, and our LLM fails to be able to understand the task and the text of the documents. So we have unstructured text, unstructured data, and we have to optimize now here our processes. Now, independent if you want to have another embedding, if you have another vector representation, if you use late chunking, and for my green grasshoppers, late chunking is explained beautifully here in this publication by beginning of October 2024. We have a problem that the text itself is too complex for an LLM to understand and to process. So what we do? Now, we have an idea, yeah? And our idea is to use AI, to use now intelligent agents here in our document ETL pipeline. And if you have been around in the 2010s, you know that ETL stands for extract, transform, and load pipeline. So this is a sequence of data processing steps. In the old times, we called it data pre-processing pipelines to integrate, clean, and store the data from various sources here for a very specific application. And now our application is simply here that those complex data can be fed into an LLM, but on a level of complexity that an LLM can handle this. And think about an LLM on an edge device, maybe on your iPhone or whatever. If you do not want here to connect to cloud instances here with huge LLMs, we have somehow to break it down here to make the LLM understand here the complex data. Now, we will build here on ETL and we'll do an agentic version of ETL. So therefore I have 1 minute to explain ETL, extract, transform, and load. Extract is simple. Data is gathered from different sources, whatever it is, with an API, from databases, from flat files, external system, whatever we have. Then we have transform. This means cleaning, transforming, structuring the extracted data here to make it consistent, bring it in a form, bring it here in a JSON format, whatever we have, what we need for filtering, sorting, joining the data from different sources, missing documents, files, Word documents, Excel spreadsheets, whatever we have. And then load. All this transformed data is then loaded into a target destination, a data warehouse, a database, a data lake, wherever we can then go on for the next step. Now, for my green grasshoppers, a very simple example here of an ETL pipeline for an e-commerce sales analysis example. Imagine you are an e-commerce company. This is your extract step with the sources. This is how you do here the data cleaning, the data enrichment, the data aggregation, and the data formatting. And then you load this, either you go with Snowflake, a big query by Google or whatever, and then you are ready to have your Tableau or your business intelligence, your Power Business Intelligence to trend, analyze sales performance, whatever you have. So we're exactly in this area. And now you might say, hey, wait a minute. In your last video, you showed us here Monte Carlo tree search, enhanced search space algorithms by AI agents that configure here new trees to explore the complete search space here, as done by Stanford and UC Berkeley. And you said, why not, if we are now focusing here on the data preparation, on the data pre-processing step, why not use the intelligence of our LLM to help us in a very specific ETL process that is absolutely in harmony then with the LLM. So the LLM prepares its own data for its own data processing. And then you have the hope that this would be a very harmonic process and the format would be compatible in the best cases. And you might say, hey, let's think about it. So in the old idea here, we had here tree structure, a node, a leaf, and then a sister leaf or a subnode, whatever. What if we build a similar structure here and have a beam search algorithm and we try to find here an optimal configuration for our ETL pipeline, but now not by humans, but with an AI. Welcome to the publication of today, October 16, 2024, UC Berkeley, Agentic Query Rewriting and Evaluation for Complex Document Processing. So what a coincidence! Here we have a brand new research and we have a look at this particular paper. And now with my simple introduction, now you are ready to go and understand exactly what we are gonna do. Now we have text. This means we have unstructured data. This means in a mathematical space we have operators defined that we can operate our mathematical operators here on those spaces. So what we have on operation, we have a map operation, a parallel map operation, a reduce operation, filter and resolve. And you say, wait a minute, baby. In the 2010s when we did here our Spark and PySpark and every big query data, we had map reduce, no? Yes, absolutely. It is absolutely the same, but just applied now on a different level if you want. So map here, it is simply an LLM-powered projection function. Reduce, absolutely. We have an LLM-powered aggregation function. So now it's not anymore the brain of the coder that writes the code, but now we say, hey, LLM, do this for us, help us here in the implementation. Filter LLM evaluated conditions. So you get the idea. And we have an equijoin, remember the old join, left join, right join, and whatever. Split and gather, yeah, exactly, we are talking here about chunking. With this simple set of operators, we are now able to tell the AI system, hey, those are all possible combinations that you can use. Maybe you have a linear chain, maybe you have a more complex star chain, or wherever you go with. Find the optimal configuration of all our operators, apply to some unstructured data, our text, therefore optimizing now here the text representation for a specific LLM for a specific task. So let's have a very short look. You know the map operation. Hopefully a map operator applies an LLM-powered projection. We know this as a semantic projection to each document that we have in the data set. And you see it is rather simple. Our map is simply defined here by an output schema here with particular structure. And we have a prompt. And prompt is analyze here the following record. And then we have an incoming document. And then you have here extract any instances of whatever event happened here, and for each instance provide here the name of a person and a brief description what happened here. So you see, it is rather easy to implement. Then this map operation, you get it here, the output schema is defined here in key value pairs as it was in the 2010s. So if you have been around coding in the 2010s, you feel so familiar suddenly with this. Support prompt using your Ginger 2 templates, yes, everything. But now the main idea why we do this is this map operation adds now new attributes from our documents specified in the form of the output schema to the existing documents. So what we have now? We have now a version that has now the original text doc, unstructured text, and the newly generated attributes. So if this text was about persons, we have now all the names of the person, whatever the person have been doing, how they have been connecting to a certain event. So we have now, if you want here, a new attribute list key value pairs here for the specific acting persons that are described, for example, in the text. The reduce operation, yes, you know this, resolve operation to consolidate information if we have multiple entities. If we have then the filter operation or an equijoin operation, if you have two databases or two data sets that we have to join, and the LLM is doing here the comparison of the two documents. These are operators that I hope you are familiar with. So, short summary, my green grasshoppers. We have a document transformation, a mapping. The LLM now interprets the document based on customized prompt to add new attributes. This is now an additional information that we have. So we have extracting entities, we have summarizing information, or we have classifying section here of a document added to the original document. If you have multiple documents, we have now a reduce function or a reduce operator, and this consolidates information from documents with shared attribute. So all the reports, all the documents mentioning here a specific name or a specific event or whatever are now aggregated into a single output. So we kind of rewrite the original text with a view how to present this content to our LLM. Yes, I told you it's gonna be simple and easy. Resolve is easy. We ensure data consistencies. And split and gather operation for the context preservation is simply, if we have really long documents, more than 2 million tokens, we can chunk them into smaller sections, process each chunk with the relevant surrounding context. Remember, we have to look at all the neighboring information, maybe the complete information, therefore enabling the handling here of large documents. And we have now a knowledge of the complete content. There are a lot of possibilities how you can build your split gather pipeline. I refer here to figure 3. So processing a single long document, split operation divides the long document into manageable chunks. Chunk 1, 2, 3, and 4. And the gather operation now augments each chunk with the relevant context from peripheral chunks. And we have here more or less 3 possible ways to do this reconfiguration, A, B, C. At first, we include fractional parts of the surrounding chunks, hopefully the one that we are referencing to, or we include the full content of the first chunk, or we include summaries of all the previous chunk. You see, whatever idea you have, whatever is important here, it depends on your specific text that is in front of you, that you want to process. You have to have a look at the text, and you have to understand about the complexity and the cross-reference and the inter-reference here of the text elements, and then you build your perfect split gather pipeline configuration. And now we have a brand new idea, and this is we have to rewrite directives. Now you would say, what is this new element? Well, it is rather simple. It is our starting point for the quote-unquote intelligence of our AI agents to start operation. We have to have a first conditional setup of our system. So the authors say we call these rewrite directives to indicate that they are an abstract framework that can be concretely instantiated here by our LLM agents in a multitude of ways. So this is, if you want, this is the first raw idea how to do it. So the authors go on more precisely. These directives are primarily designed to optimize the quality of the outputs from the DocETL pipelines through some logical decomposition of individual operations. And we focus on rewrite directives for our operators, map, reduce, and equijoin operators with filter operators. And we can organize our rewrite directives into 3 categories. They have now data decomposition. We will go to look at this. Projection, synthesis, and LLM-centric improvements we will also have a look at and have a simple example. So, these rewrite directives are intentionally real abstract, serving here as scaffolds for infinitely many specific roles. So it's, if you want here, a sphere. So the actual instantiation here and the actual code application of these directives are in the next step carried out by our LLMs, by our agents. We will have 2 specific agents for this task, and they will be able to interpret here the directive in the context of the specific task and your specific unstructured data of your specific documents. And this is the beauty. Now we have not just one idea that should work for all documents. We have 10,000 different documents from, 1,000 different people, and everyone writes a little bit different. Somebody writes in a mathematical style, somebody writes in an analytical style, somebody writes only for financial data. And now we have here specific tasks and specific data directives. So let's start with the first example, data decomposition. It is crucial when dealing with large documents or when there are too many documents to fit in a prompt and get an accurate result for, let's say, a little large language model that you have operating here on your phone. So this directive breaks down a complex map operation into splitting the document into multiple, each corresponding to a chunk, gathering the peripheral context for each chunk, applying a modified map operation for the chunk, and applying a reduce operation to the results of this. So you see our old map reduce now here in operation by an AI agent. The prompt corresponding to this new map operation might basically include a statement that only a portion of the original document is being processed. Beautiful. And then data decomposition is crucial when dealing with large documents. And when we split the document, as I've shown you before, they focus now on 3 types of context that proves particularly useful. They focus here on document-level metadata, on hierarchical information in the text, and on summaries of neighboring chunks. So if you really chunk it up, you are not left only with your single isolated chunk, but you have a summary of all the neighboring chunks going 3, 4, 5, 6, 10 chunks to the left or to the right, before and after your particular chunk, to include this information. Or, as I showed you, we have LLM-centric improvement. So now we focus here on the LLM, and this category addresses here the unique behavior of LLMs that can be leveraged for an optimization. And here one very particular is gleaning. I would like to show you this. This is also a map and reduce operation. We rely on the insight that when prompted with the previous inputs, the previous outputs, and then we ask the LLM, hey, now improve in a second run the output, the LLM can now iteratively refine the output. So if you provide now in the second run a little bit of additional information to help the LLM to understand, for example, the feedback that it got from the first run, it can iteratively refine now the second output that it produces. Yeah, I told you this. We have here the process here works as follows. The data processing LLM performs here the map operation of the input data. Then we have the evaluation step, and we have here a separate validator LLM. It evaluates now the first output of our data processing LLM. So it receives the original prompt, the data processor's LLM response, and a task-specific validation prompt. And the validator LLM now determines if a refinement is needed, or it provides some specific feedback on how to improve the output if it is necessary. So we have now our second LLM evaluating this with a little bit more information. And if it is necessary, we have a refinement step. The data processing LLM refines now the previous output in the second run and includes now the validator's feedback if the validator tells him, hey, also look, I don't know, at another event that happened and understand what was discussed over there, and then integrate this knowledge in your second output. So this LLM retains the chat history, including all the original prompts. This is what is in the memory of the agent, its previous response, and the validator's feedback, allowing it to refine rather than regenerate from scratch. And this is here the perfect starting point here for an iterative improvement for a self-learning loop. Beautiful. Now that we have this directive to rewrite here the original content, now we can bring in our two agents. I already mentioned them, but now officially let me introduce you to the two agents. We have a generation agent and we have a validation agent. So I almost told you everything about it, but let's do it again. The generation agent applies here the logical rewrite rules. You remember step 1, to create now a real diverse set of candidate plans of real code implementations. And the validation agent, you're not going to believe it, takes now these candidate plans, takes the code of it, and runs it and assesses the quality of the output produced by those candidate plans. So per operation with our operators, or if we choose from the complete ETL pipeline, the data pipeline, now a specific sub-pipeline, the validation agent, plural, evaluates now all candidate sub-plans on a data sample to select now the optimal sub-plan. So what we have trial and error. The system is just trying it out. It says, okay, so give me the code for your sub-plan, for your particular sub-pipeline, and I will calculate it and I will evaluate the outcome. And then I can tell which is the optimal sub-plan for your specific task, for your specific ETL pipeline. So you see, the framework iteratively refines here this ETL pipeline by applying the rewrite rules and evaluating here specific candidate plans using here our two LLM agents. One writes the rules and the other evaluates the rules. This ensures that each sub-pipeline is optimal in terms of resource usage and output quality. And this can be quite computational expensive, because if you start at a non-optimal position, it might take quite some time and time before you get here to the optimal output quality. If you would see here the original pseudocode, here we go. This is our optimization process. At first we start off with the pipeline optimization here. Then we feed in here, we select here, of course, sub-pipelines. We optimize those sub-pipelines. Here you see the algorithm 2 for the sub-pipeline optimization. And if we have a plan selection, this is algorithm 3. So you get the idea. The system is simply here generating here for a particular pipeline a lot of variety of different sub-pipelines with different code segments, with different code elements, with different methodologies applied here for your specific candidates and for your specific task. And then after trying it out, evaluating it, and coming back and says, hey, for my 112 runs, in the run 79, we got the best result. So, beautiful, this is it. So let's just clarify the terms that we used and a little bit of the process terminology. So what is new? We have main two elements, the rewrite directives and the agent-based rewriting and the evaluation process. Great. So those rewrite directives, if you read it, it's not immediately clear what it are. They serve simply as abstract guidelines, or if you want, rule of thumb for improving the ETL pipeline, but they do not execute any changes or any optimization directly. They specify only some potential ways to optimize here the data processing based on common patterns. So they just give you the starting point. You know, if you have a particular problem and you have a particular data format, they say, hey, yeah, looking at, I don't know, our knowledge, we think we could do it either in this way, A, or in the way B, but maybe there's a little chance for the way C. And those are your 3 start configurations that you will start your process off. But once you started, you have now AI agent. So we have now agent operationalize now this directive by generating these configurations and validating this configuration in code, applying and fine-tuning now the rules in a hands-on way to achieve optimal results. So they embody here the logic of the directives, but are also empowered to adapt them based on the real-time feedback. So this is our coding, our writing, rewriting, and evaluation AI agent structure. Now, careful, this rewrite directives, I did not immediately understood if it comes now from the LLM or from the human. Now, in their framework here, UC Berkeley, they say they start here with human crafted ideas. The human developers sit down and they say, hey, we have experience with this data pipeline. This works well. We're using it now for 2 years. So the first predefined rules are crafted here by the human developers. And then from there you start. Now, of course, you could theoretically say, hey, if I have a database with, I don't know, 1,000 ideas by human developers, how they approach each specific problem for each specific data format, for each specific task, for each specific multitude of documents that are written in a certain complexity level, then we use this methodology. Yes, we could build also an AI system, but for the moment we have here as a starting point the human developers. And then our agents, if I say agents, LLM-powered generation and validation agents do the work for us, the coding. Maybe pipeline, plans, and sub-pipelines. Let's be really clear. So the pipeline, the ETL pipeline, is the entire ETL process from start to finish, encompassing all the data extraction, transformation, and the loading operation. What is a plan? A plan is a real specific configuration of steps, like how to do the operator algebra of map, reduce, filter, split, and gather, that a pipeline follows to process here the data. So a plan includes all the details you need on which the operators to apply and how they interact in a linear sequence, for example. Sub-pipelines, yes, you guessed it, smaller section of our main pipeline that now we pick out and we try to optimize. So if a pipeline has, let's say, 10 sub-pipelines, we look at each of those 10 sub-pipelines and we try to optimize the smaller section of the main pipeline that only focus on a very specific set of tasks and operators. And if we can break down this pipeline into even simpler sub-pipelines where we have code that runs faster, is less error-prone, and we can optimize each sub-pipeline. You see, it's so easy if I explain this to you. Rewrite directives. This is a brand new idea, so applied either individual operators or they are specific to sub-pipelines, depending on the complexity and the requirements of the task. When a directive is identified as potentially useful, it's applied to create one or more candidate plans for that particular pipeline or sub-pipeline, depending on the level that you operate. So the plan includes the instruction on splitting, merging, transforming data for optimized processing. And a plan, as I showed you, might involve multiple operators working together in a linear sequence or whatever. Yeah, there's also parallel mapping exercises, and a plan for a sub-pipeline could involve splitting document into chunk and then performing parallel map operation on each chunk to extract the information effectively. So, however you design the chain, linear or not linear, parallel or not parallel, of your operators on unstructured text, you do this for the complete ETL pipeline here in a plan. The plan defines here exactly here the sequence of multiple operators, and then you use your two agents here, the generation agent and the evaluation agent, to find the optimum of the system. For my green grasshoppers, what is the task of the generation agent, the plan creation, the parameterization, and the sub-pipeline variants? And for the evaluation agent, the output is now evaluated by this agent. You have a plan selection based here on the performance, and you can start your iterative refinement. Let's talk about the performance. And I put in now the information about the workflow. Okay, so from the rewrite directive to the optimized pipeline, identify all the applicable directives, generate here the specific candidate plans, evaluate each and every plan, select and integrate then the best plan. And finally here in the word of the authors, you see Berkeley. Our evaluation across 3 unstructured document analysis tasks demonstrated that our new DocETL can find plans with outputs 1.3 to 4.6 times higher quality than hand-engineered baselines. So, of course, it takes time for the system to find its optimum. It takes time to try out all the different permutation, alteration, combinations that we have. And it is almost a little bit like the one that I showed you here with the tree search and the beam search algorithm. This is now to applied here on the perfect data pre-processing, on the pipeline here before the data come into the prompt. So how do we structure complex text documents here in a way that an LLM is able to perform its task with the highest efficiency? Yeah, let's look at the code. We have complete code. Yeah, beautiful. We have here, as you see, just 2 days ago, 12 hours ago, beautiful Python workflow. We have an MIT license. Isn't it beautiful? They explain here everything. You even have a specific website if you have a demo. This is nice. You have a Discord. Everything is available for you. And I hope you saw that now. We are moving now really into the data preparation pipeline for our LLMs. So we use LLMs more or less to kind of rewrite complex documents in a way that our LLMs understand this document and have a perfect prompt structure for the input. Now, of course, there are limitations, because if you have a real complex document and you have a little LLM, and the little LLM tries to understand the complexity of the document and rewrites the document in a way what the little LLM think is the real contents and breaks it down into simpler tasks and extracts some particular pieces of information and maybe neglects other part of the information. You see, it all depends here on the power, on the processing power and the understanding on the complexity level what an LLM is able to handle. So There are massive limitations, but there are also, if we look here at the workflow level, at the process level, it is a great idea to use here the LLM that we have already in the loop here in our complete pipeline for the agentic optimization of our document ETL pipeline for unstructured text. I think this is it for today. I hope you enjoyed it. I hope you found a little bit of new information or a new idea. And it would be great to see you in my next video.